Let's take a look at a Cascade PID tuning example using pidbot. In this system we have a steam flow valve FCV102, which is adjusting the flow rate of steam to a tank jacket. Product is flowing through the tank, being warmed by the jacket, and warm product is exiting through the bottom here. So in this system we have two control loops. We have this steam flow control loop, which is simply adjusting the flow rate of steam to a desired set point. And we have the product temperature loop, which is controlling the product temperature by adjusting the set point of the steam loop. So when you tune a Cascade controller, the first thing you want to do is focus on the secondary loop, sometimes referred to as the inner loop. In our case, that's this steam flow control loop. So I'm going to open up the tuning dashboard component for FC102, our steam flow control PID, and I'm going to start recording data and put that loop in manual. We want to allow the loop to reach a steady state in manual and collect a little bit of steady data. There's a little bit of noise in the steam data, but the process itself is steady, so we can go ahead and bump the process. I'm going to bring it down to 30% on the steam valve position. And we can see a nice clear response in the steam flow rate. I'm going to bump the valve back up to 70% and get a little bit more data. Again, a nice clear response in steam flow. So I'm going to go ahead and model the process. Notice that the steam flow process is a self-regulating process. In other words, it reaches a new steady state when the CV is changed. So we have the first order plus dead time process selected. And I'm going to model the first bump starting at steady state. And I'll model the second bump also starting at steady state. And I'll just model both the tests together. So here are our process models down here and our average model here. That all looks good, so we can go ahead and tune the PID controller. So we can see our existing tuning values are pretty oscillatory. This is the response shown in gray with the existing tuning values. The blue response is the new tuning values. So we'll make that a bit faster. Maybe just a little bit of overshoot, not much at all. And that response looks good, so we'll accept those values. And now our inner loop has been tuned, so we're all set with our steam loop. Now that we've finished tuning on the secondary loop, I'm going to put it back into Cascade mode. So now the secondary loop is going to accept a steam flow set point from the primary loop, and we can tune the primary loop just like any other PID controller. So I'll open up the tuning dashboard component for TC101 and start recording data. And I'll record a little bit of the product temperature data at steady state. And then we can bump the control variable, which is the steam flow set point, down to 100 pounds per hour. And you can see the response of the temperature control loop is much slower than that fast steam flow control loop. And that's actually important for a Cascade. The primary loop should always be much slower than the secondary, or else you'll get some interaction. And we have some nice clear temperature response data. And typically I would allow that to steady out again and do another bump test, but we won't wait for that. In this case, we'll just go ahead and model this response. Again, this temperature loop is a self-regulating loop, so we'll model it with the first order process. I'm going to start at steady state and model that range. And I'll just do that one more time. Make sure everything looks good, which it does. And we can go ahead and tune the primary loop now. So the gray line represents the existing tuning values, and the blue line represents the new tuning values. And that looks like a pretty good response there. Maybe we want to slow it down just a little bit so we don't get any overshoot. And we can go ahead and accept those values. And we're all tuned up on the primary loop. I'll go ahead and put it back in automatic mode. And we'll bump the set point just to see how we're doing. And we should expect the product temperature to come right up to 120 degrees with very little overshoot. And that looks good right there. So our Cascade tuning is complete.